Section 5.3, Function Notation. Let's start off with the definition of function notation. The dependent variable of a function f can be represented by the expression formed by writing the independent variable name within the parentheses of f parentheses. When we do that, we would say the dependent variable is equal to f of the independent variable, and we would call this representation function notation. Alright, so that's a pretty confusing definition, I think, when you first see it. So let's try and deconstruct this, thinking about our normal way of writing an equation where x is the independent variable and y is the dependent variable. So if we just translated that, we would be saying y is equal to f of x. And so what we want to think about with function notation is we're taking what would have been the y in our normal equation and we're replacing it with this new notation, f of x. So consider the following functions: f of x equals negative 3x squared plus 5x minus 7, and g of x equals negative 4x minus 7, and find each of the following. So first of all, these are just two different functions where we took what would have been the y and replaced it by f of x. So you can just think of this equation as being the same thing as y equals negative 3x squared plus 5x minus 7. When you have multiple functions, you want to be able to tell the difference between them. So we wouldn't call them both f of x, we would pick a different letter called the function name. So this one is y equals negative 4x minus 7, but we replace the y with a g of x. So there's maybe one of our first benefits of function notation. We can differentiate between the two y values by using their names f and g. Alright, so now how does this function notation work? If they ask us to find f of negative 2, then if you look at the notation, this negative 2 is inside parentheses, which means it's like the x. You could say they took this x and substituted negative 2. So what we would want to do, if they substituted a negative 2 right there for that x, we would also want to substitute negative 2 here and here for those x's. So when they put a value inside parentheses, they're just telling us to substitute that in place of the x value. So that's what I would do. So I'm going to write the original function down, just copying all of this, but every time I get to an x, I'm substituting the negative 2 because they had put that in place of the x in the notation. Alright, and from there, you're just simplifying. So following order of operations, we'll go ahead and do the exponent first. So that would be negative 2 squared, which is 4. We can work on this piece at the same time. 5 times negative 2 would be negative 10. And we have this other minus 7. We've got to do this multiplication next. So negative 3 times 4 is negative 12. We could go ahead and combine these. Negative 10 and negative 7 would be negative 17. And then these are both negative, so add them up and we get 29. And because they're both negative, the answer would be negative. So most of that was simplification. The new thing was knowing what they meant by f of negative 2. And again, they substituted in place of this x a negative 2, so we just substituted in place of the other x's a negative 2. So whenever you see a number inside the parentheses of function notation, that doesn't mean g times negative 3. We would read it g of negative 3, and it means that we need to substitute this value in place of the x's in the function. So g of negative 3 instead of negative 4x minus 7 would be negative 4 times negative 3 minus 7, or we're just substituting that negative 3 in place of that x. From there we just simplify. So negative 4 times negative 3 is 12, minus 7, and 12 minus 7 is 5. And then just to kind of make sure we get that idea down, we'll do one that looks a little bit weird. G of b plus 2, if they're replacing the x by b plus 2, we would do the same thing in that function. So we're going to write negative 4, and then it's supposed to be that x, but we're going to substitute this b plus 2, and then copy the rest of the function, minus 7. So no matter what they put there, whether it's a number or some other expression, because it's replacing that x, we would also replace that x by the same thing, the b plus 2. And then after that, we would just simplify. So distributive property, negative 4 times b is negative 4b. Negative 4 times positive 2 is negative 8. And then we have this negative 7 here. Those two are like terms. So carry down the negative 4b, combine our two like terms there, and we get negative 15. Alright, and then for the final one, we have f of a over 2. So we have something messier, a fraction expression, but the rule still doesn't change. we need to take this a over 2, which they substituted in place of that x, and substitute it in place of those x's on the other side of this function. So let's see, we've got negative 3 times x squared, so we'll substitute the a over 2 in place of that x. And then it's plus 5x, so we'll put 5 times, and then substitute the a over 2 there as well. And then there's a minus 7, so we'll do that. After that, we'll just simplify a little bit. We have the negative 3, square top and bottom of this, so squaring the top we get a squared, squaring the bottom, 2 squared is 4. On this one, I would think of this as like 5 over 1 times a over 2, and then we have the minus 7. So just one last step of simplifying. Here, this is like negative 3 over 1, so multiplying the numerators, negative 3a squared over 1 times 4, which is 4, plus numerators here, 5 times a, and then denominators here, 1 times 2, and then the minus 7 we just copy over. Now it's possible we could get a common denominator for all of that, but I believe on my math lab they'll ask you to leave it just like this, with just the terms separated. What they mainly want you to see is what do you do with that a over 2 when you substitute it in place of the x's in the original function. Alright, let's go ahead and look at a few more examples. Consider the function f of x equals 5x minus 8. Find the value of x that leads to the given value of the function. So they've given us f of x equals negative 8. Now if that negative 8 had been in the parentheses, that would make it an x value and we would put it right here. But because they're saying f of x equals negative 8, that makes it a y value, and we will replace this f of x by this negative 8 because negative 8 is equal to f of x. So you have to pay attention to where is the number. If it's inside the parentheses, it's an input or an x value. If it's equal to f of x, it's a y value, and it would replace f of x. So instead of writing f of x, we'll write the negative 8, and then that's equal to 5x minus 8, and then from there, we just go through and solve the equation. So we're trying to get x by itself, so I would add 8 to both sides. That cancels these. It also happens to cancel them on the other side, which wasn't necessarily the plan, but that's okay. Negative 8 plus 8 is 0. 0 equals 5x. We're trying to get that x by itself, so divide both sides by 5. That cancels the 5's. And then 0 divided by 5 is 0, so x is equal to 0. And I just want to point out real quick that it makes sense that our answer would be an x value because they said find the x value that leads to the given value of the function. So even though we did this different than on the previous page, it seems like we're doing the right method perhaps, right? Because they were asked to find an x and we found an x. So similar, on part B, f of x equals 7, or 7 equals f of x. So the 7's not inside, it's equal to f of x, so it's like a y value. But really, you can just think of it as a substitution. Instead of f of x, if f of x equals 7, we'll write a 7 right there. And then that's equal to 5x minus 8. And then we just do the algebra like on the last one. In fact, just like the last one, because we're trying to get this x by itself, we'll add 8 again, just like last time. This time, the 8's over here don't cancel out, so we just add the 7 and the 8 and get 15 equals 5x. But just like above, we want this x by itself, so we divide by 5. 5 over 5 is 1, so that goes away. And now we just have this x here equal to 15 over 5, which would be 3. And again, once again, finding an x value, which makes sense because they gave us a y value and they were asking us to find an x value. So we can even do that if it's a fraction. We might not be as happy about it, but it's still the same process. If they're saying f of x equals 2/3, then that's a y value, and it replaces this f of x right there. So we get 2/3 equals 5x minus 8. The difference with this one is it has a fraction, so we would want to clear those off. So I would multiply both sides by 3. If I do that here, those will cancel. And then I would multiply all of this by 3, so that I'm multiplying both sides by 3 and it balances out. And then it's just a matter of simplifying from there. So these 3's cancel. This 3 I would distribute. So that is just a 2 on the left after the 3's cancel. And then 3 times 5 is 15x minus 3 times 8 is negative 24. And then trying to get that x by itself, so add 24 to both sides. And then, where does that put us? 26 equals 15x. Divide both sides by 15. Get that x by itself. And we get x equals 26/15. And we would want to reduce that if we could. But 15 only has factors of 3 and 5. And neither 3 or 5 goes into 26. So that would be our end answer there. We'll point out that on the top two, they told us what to put in for f of x, and we did the exact same algebra steps, which was to add 8 and then divide by 5. On this one, when they asked us to substitute the 2/3 in, we could have actually done the same steps. Again, add 8 and divide by 5 to get that x by itself, but then we would have had to work with the fraction 2/3 all the way through. So it's kind of nicer to multiply by 3 right away and clear those fractions instead, but either way would have been okay. All right, let's go ahead and look at another example. Let's use the table provided to answer each of the following questions, and this will also give us another chance to think about the notation some more. So they want us to find f of 3, where we don't have the equation this time, but we have a table of values of the function. But we learned from what we did before when we did have the equations that if the 3 is in parentheses like it is here, that means it's an x value. So that's this 3 right there in the x column. And f of 3 would represent the y value. So according to this table, if the x value is 3, then the y value, or f of x value, would be 2. So apparently f of 3 equals 2. So it doesn't feel like we're doing much there, but we are practicing the notation. We're thinking about whether that 3 was an x or a f of x value because it was in the parentheses. It was like an x value. So over here, when we have f of x equals 0, this time the x is unknown, so that's what we're trying to find, and they do say that here as well. So this 0 is a y value, or just an f of x value, which is the way it's labeled. So if f of x equals 0, so here's 0 in the f of x column, but oh, wait a minute, here's 0 also, right? So this one's a little bit strange in the sense that we don't know which of those lines they're talking about, but for this 0, the x was 0, and for this 0, the x was 4, and we don't know which of those they were talking about, so it could have been either. So we actually have two answers to this. When is f of x 0? Either when x is 0 or when x is 4. And in my math lab, they would probably have you separate those answers with a comma, so just 0, 4. But you'd still have the two answers. And you can even check those to see if they work. If x is 0, f of x is 0. If x is 4, f of x is 0. So either way, you plug either of these in for the x, the 0 or the 4, and you end up with an f of x is 0, which is what they want. So maybe a bit of a surprise that we got two answers, but that does happen sometimes when you're given the output instead of the input. For functions, if they give you the input, there should only be one answer. Another example, use the graph of y equals h of x provided to answer the questions. So we've done some stuff with function notation now when they gave us equations and when they gave us tables. Now we're going to try it when they give us a graph. So this graph right here is the graph of y equals h of x. So they're saying we've got x as our input variable, and then the y value, it would also be thought of as the function. So when they ask us to find h of 1, the first thing we have to think about is that 1 an x value or a y value. Because it's in parentheses, that is an x value. And they want us to find h of that, which would be the y value according to this up here. So we do this just like we did way back in chapter 1 when we were given graphs like this. So the x is 1, so go to x equals 1 on the axis, and then drop down until you hit the graph. That's the point on the function we want, but we want to know what is the y value there. So once we hit the graph, we go across to the y value, and the y value appears to be -3. So you could write that, y equals -3. But they want to know what h of 1 is, but y and h of something are the same. So if y is -3, that means h of 1 is -3. And we wouldn't want to say h of x equals -3 because this y value of -3 is the specific one that goes with an input of 1. So we want to make sure we're saying h of 1 equals -3. All right, and then another one. They're asking us to find x, so they're probably going to give us a y in that case. And they do, because they say h of x equals -1, but h of x is just another way to write the y. So similar to the last one, but this time because it's a y value, we would go to -1 on the y-axis, which is right here. We would go across until we hit the function, and then from there we would go up and see what x value is that, which would be right here. Looks like x equals -2. And that is our answer. And you could test it too. If we plug in -2 into the function, that's here. What's the y value? -1. All right, find the domain of h and find the range of h. So these are new terms for us, and so we need to think about what they mean. The domain of h is the set of all possible x values that are on this graph or a part of this function, and the range is all the possible y values on the function. One of the ways that often is a good trick for doing that is think about if you're going to draw this function on your graphing calculator, and think about the smallest rectangle you could have that would contain the whole graph, and then think about what the window settings would be on your graphing calculator to make that happen. So if you were going to graph this and you wanted this to be your window so that the graph is contained in there but there's like no extra space, then what would be your x min and your x max, and that will be the domain. So the smallest x, or the far left side of this box, is -5, and then the x max would be the far right side of this box, which is at this point x equals 4. And then what x's do we have for our graph? We have all the x's in between -5 on the left and +4 on the right. So when they ask you for the domain of a function, they're asking you for the set of all possible x values, and thinking about this graphing calculator window as a trick can be helpful for that. When they ask you for the range, they want you to do the same thing, but just for the y values. So what are the different values of y that this could possibly take on? So think about the window. How far down is this? Always go from small to large. So the small end is down here, and that's a height of -4. And then the top of that window is right here, and this was the origin, so that's up 1 unit, so that's a y value of 1. So the x values go from a low of 5 to a high of 4, -5 on the left, 4 on the right, and the y values go from a low of -4 to a high of 1. And the x values represent the domain, and the y values represent the range. All right, one final example in this section. Find the intercepts of the function f of x equals 4x plus 2, and then sketch the graph. So the key thing is just to remember f of x is just another way of writing y, so this is really just y equals 4x plus 2, which is an equation of a line, like a y equals mx plus b sort of thing. So we've done plenty of these, it's just we're not used to seeing it this way, so feel free to just rewrite it this way to be comfortable with it. Remember that when they want the intercepts, we would plug in a 0 for x to find the y-intercept, and then we'd plug a 0 in for y to find the x-intercept, so we'll want to do that. If you plug a 0 in for x, you get y equals 4 times 0 plus 2. 0 times 4 goes away, so y is just equal to 2, which makes sense because in the y equals mx plus b form, this should have been b, the y-coordinate of the y-intercept. This one will be a little bit more work. Plugging the 0 in for y, so plugging the 0 there, and then trying to find the x. So 0 equals 4x plus 2. Got to do a little bit of algebra this time, so subtract 2 from both sides. -2 equals 4x. Divide both sides by 4. That gets x by itself, and then just simplify by reducing that. You can cancel a 2 top and bottom, and this would be x equals -1/2. And then it's usually common that they want to know which is which, so it's nice that you found them, but it's important you know which is which. So if you think of this as 0, 2, that would be the y-intercept, and then think of this as -1/2, 0, and that ordered pair would be the x-intercept. Remember, intercepts are an ordered pair. And when we go to graph it, notice all the numbers are small, so we could just go ahead and do the standard numbering of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in every direction, these being the negative directions here and here. And just plot the points we have over 0 up 2, left a half and up 0. There's 2 points, that's enough to draw our graph. So bring in a ruler or something to help us draw the straight line. connect that in. And they did ask us to graph by doing intercepts, so plotting those points is the way we should do it. But we should also think about the slope. The slope is 4, which means we should have a line that goes up and is fairly steep. And we do have a look like that, and we have our y-intercept right here of 0, 2. So you can use what you know about y equals mx plus b as kind of a double check. But if they ask you to find intercepts, make sure you're finding them and labeling them and using them. Especially in my math lab, if they ask you to graph using intercepts and then you just graphed using slope and didn't use these two specific points, you might get the graph right but still be marked wrong because you're not using the intercepts. So pay attention to the directions. If they're just saying graph, go for it kind of anyway. But if they're saying to use the intercepts, then you have to do it this way and show both of those points in your graph. All right, that wraps up this section.